Hello, this is a demonstration of clicker training in robotics from the University of Idaho Laboratory for Artificial Intelligence and Robotics. This robot will start out not knowing what to do at all within this environment. Notice that the environment is very messy, trying to simulate a real-world environment, sort of the way a house would look, or maybe a messy house. The trainer is going to try to get the robot to approach these green bricks, which, from this old camera, will look as just a dark blur in the background, similar to what the cubby over there might look like from the camera's perspective. As the robot moves around the environment, it'll approach what we consider different states, because the states of this robot all come from the camera. So as it approaches the red felt, when it gets within, say, 1 to 2 feet, the felt will begin to look like a big red area on the camera. And as it approaches the green bricks, the bricks will appear to be a bigger, greener, more defined color on the camera. This means that as it approaches these different areas, it enters a different state of its environment, and it won't know what to do at those different parts as it approaches. In the beginning, the robot will just run a random algorithm where it walks around and does nothing. It can turn left, it can turn right, and it can go forward. And a trainer will begin to give it feedback on whether or not it thinks it's doing the right thing. It's a good job or a bad job type of signal, similar to what we see with animal clicker training. Once the robot's received enough input that it can begin learning, that is a signal for each of its given actions, turning left, turning right, and going forward. Then it will begin to run an evolutionary algorithm to train the neural network which drives the robot. After each movement, the robot will wait just a moment to see if the trainer wants to give it any feedback. And it's during this wait period that the robot will evolve just a couple generations of the evolutionary algorithm. It's a genetic algorithm that trains this neural network. Now the learning algorithm has begun. Each of these pauses, the robot will take the time to do just a couple generations of evolution.
25 generations time. Best fit 4.659.
The trainer is allowed to look through the camera and see what the robot sees. The robot's behaviors become quite a bit more correct as the robot begins to have more and more generations of evolution. But still, as it approaches a new state, such as being able to see the green blocks, it gets confused, not knowing what to do. Then it falls into old patterns of behavior.
Best fit 5.123.
It's up to the trainer to discern whether or not the robot is doing good things or bad things, and give feedback to the robot. Again, as the robot gets close to the green bricks, which it can't see right now, it gets confused and doesn't know what to do because it's a new state for the robot. Once the robot approaches the green blocks once, training is stopped. It's only allowed to approach the green blocks once because we want there to be a fairly high rate of failure. If this robot was trained multiple times to approach green blocks and given hundreds of generations of evolution, it almost certainly succeed every time. But because we're trying to test two different modes of learning, we want it to have a fairly high failure rate. Now that it's been trained, we're going to put it into autonomous mode, where it's going to not pause at all waiting for trainer feedback. In fact, if it receives clicks, it will ignore them. And no learning's happening, and we're just going to observe the behaviors. If the robot goes off the row or off the white boards, the training will be called a failure. Or if 2 minutes pass with the robot fishtailing in the corner or not approaching the green blocks, that is also a failure. During data collection, the robot was made to face both opposite corners without looking at the green blocks to see if it could succeed with different background environments and in a different position. This one did quite well, but not all of them do.